Maxima minima from the exercise 6.5 as per the old volume, old edition. I'm doing from the 12th sum. F of x is equal to x plus sine 2x. They've given close bracket. Close bracket is there. You should be careful. 0 to 2 pi because finally you should substitute 0 and 2 pi in the function. Now differentiate it. You'll get 1 plus 2 cos 2x is equal to 0. A cos 2x is equal to minus 1 by 2. Where all will cos be negative? All school taught to children, second quadrant, third quadrant. So it's pi minus pi by 3, which is 2 pi by 3, and a pi plus pi by 3, which is 4 pi by 3. Obviously, it's about a cos value. Where will cos be 1 by 2? 60 degree, pi by 3. So pi minus pi by 3, pi plus pi by 3. Substitute all this in the question. F of 2 pi by 3, f of 4 pi by 3. Apart from that, you should also do f of 0 and f of 2 pi, close because of the close interval. F of 0 and f of 2 pi. And compare those answers to see which is maxima, which is minima. So this is 2 pi by 3 plus sine of 2 into x. So 4 pi by 3. So a 2 pi by 3 plus sine of this 4 pi by 3 is pi plus pi by 3. A pi plus is in the third quadrant, so minus sine pi by 3. And a sine 60 is 1 by 2, a 2 pi by 3 minus 1 by 2. Sine 60 is root 3 by 2, minus root 3 by 2. So let's go to this is 4 pi by 3 plus sine of 8 pi by 3. A 4 pi by 3 plus sine of, this can be written as 3 pi minus pi by 3. Makes sense, right? A 3 pi minus will be in the second quadrant, as you can see. This starts with 0, then pi, then 2 pi, then 3 pi. 3 pi is here. 3 pi minus will be in the second quadrant and is even integral. So it's sine pi by 3. A 4 pi by 3 plus a sine 60 is root 3 by 2 plus root 3 by 2. F of 0. 0 plus sine 0 is just 0. So 2 pi. It's 2 pi plus sine of 2 into 2 pi is 4 pi. And anyway, it's going to be 0 only. So the answer is 2 pi. So you have to check which is the greatest value and which is the least value. Okay, and you can see here it's 2 pi. It's 4 pi by 3 plus root 3 by 2. And from this, we can see that this will be the maximum value, I think. Yeah, so this is my maxima, which I'm getting at when I'm substituting 2 pi, which is my local maximum point. Local maximum point. And this is called the maxima. Okay, so what is minima? 0 is the minimum value. And so this is called minima. And this 0 is called the local minimum point. So you understand that question. So that's about that. Find the maximum minima lying between 0 and 2 pi. It's incidentally, the maximum minima lies in this 0 and 2 pi. So if you forget to substitute that, you won't get the answer. So that's about it. So let's go to 13th question. The 13th question is find the two numbers whose sum is 24. So x plus y is equal to 24. The product should be largest. X into y has to be maximum. So in order to differentiate this, you can write y as 24 minus x and substitute here x into 24 minus x. And if this has got to be maximum, you have to differentiate this. Either you can take it inside and differentiate or do it as u and v. Now I'm taking it inside. It's easier for me. So it's 24 minus 2x is equal to 0, 2x is equal to 24, x is equal to 12. So that's when it may be maxima. The function is either maxima or minima. I don't know. There's no, I just get 12 and that I can substitute and get it here, and y also turns out to be 12. So then to really understand whether it's maxima or minima, take the differentiated value. This is what is already differentiated value. Take this and differentiate it again, you get minus 2. When the double differentiation d square y by dx square is negative, the answer that we got will be actually maxima. So that, we haven't got the answer. We're just talking about the point, which is the local. This x is equal to 12 is my local maximum point at which this function is becoming maximum, and at which case y is also becoming 12. So you have to break it down. The two numbers has to be 12 and 12. That's when I'm getting my maximum. Done the double differentiation also. So let's go to next sum. So then they're asking for the Product, if they ask you for product, in the product will be x into y, which is 12 into 12. So the maximum value could be 144. That's the maximum value, maxima. Maxima. Okay, so let's go to 14th question. The two positive numbers x and y is such that x plus y is equal to 60. So you can write y as 60 minus x. The question is x into y cube has to be maximum. So this is your function f of x, and you can write y as 60 minus x the whole cube and then differentiate. Or you could have also written x as 60 minus y. So then the differentiation becomes easy in that case. So you could have taken 60 minus y into y cube. And so that everything is in terms of y. So you can't call this function as y therefore. So you should continue to call it as f of x. And when you differentiate, you should continue to call it as f dash of x. Because normally f of x is y. But in the sum, there is something called a y which has been variable. So then therefore keep it like this. Now you can differentiate it as, you can take it inside and also differentiate 60y cube minus y to the power 4. And let's differentiate. I have not even differentiated. It's still f of x only. So f dash of x becomes 180 y square minus 4y cube is equal to 0. 180 y square is equal to 4y cube. So you know y and y can get cancelled. So 4 and 1, 180, 4, 4s are 16, 5 4s 20. Y is equal to 45. And so x is equal to 15. Thus you get the two numbers. And are they asking for the product? Find the two positive numbers x and y such that, and they're not asking for the product actually. So then just find the two numbers. We've already done that. You want to know if it's maxima for sure. Where is the differentiated value? This is the differentiated value. Take it and do a double differentiation verification. It will be 360 y minus 12 for 3 so 12 5 square y square. And you know y you got it at 45. You got at that point. So y as 45. So substitute 360 into 45 minus 12 into 45 the whole square. You just have to think whether this is going to be positive or negative. That's all. Okay, so then but I can take a 45 out. I can also take a 12 out. And 12 twos are 24. 24 means 24 minus 36 is 120. So into 10. 45. I'm taking a 12. A 360 divided by 12 is how much? This is 6. This is 180. 30. Taking a 45. I'm also taking a 12. 3 is 36. Yeah, sorry. Minus. A 45 has been taken out. One of the 45. There's a 12 has been taken out. So only 145. That shows it's negative. And that shows that this is a local maximum point. You understand? And so that's easy. So just verification, you don't have to really sit and calculate it. So let's go to next question. The sum number 15, is it? I just finished 14, 13. Okay. So I have to do 14. Sum number 14. Find the two positive numbers x and y such that x plus y is equal to 60. X into y cube. Yeah, I just did that. X into y cube. So that happens to be sum number 14. Yeah, I have to go to sum number 15. Sum number 15. Find the two positive integers, so numbers such as x and y, such that the sum is 35. The products has to be maximum. So in this again, you can choose to write whatever you want. I would write y is equal to 35 minus x. 35 minus x. Y is equal to 35 minus x square into 35 minus x whole to the power 5 is what is f of x, and I'm going to convert into one variable. I'm going to differentiate it. முதல்ல இருக்கிறது அப்படியே இது. Second one can be differentiated as 5 into 35 minus x the whole to the power 4 into minus 1 plus the second one as it is. And the first one differentiation is equal to 0. Here straight away I can cut this off. And I can straight away cut this off. So I got a minus 5x. The minus can be taken out is equal to taking this to the other side. 2 into 35 minus x. A 5x is equal to 70 minus 2x. A 7x is equal to 70. X is equal to 10. Y is equal to 25. And these are the way it's breakdown. We don't know its maxima or minima. So take the differentiated value. Where is the differentiated value? Before cancellation. Oh, I seem to have cancelled it. So without cancellation, what was the differentiation value? It was x square into 5 into 35 minus x the whole to the power 4 into minus 1 plus 35 minus x the whole to the power 5 into 2x. So to predict the double differentiation is to do the double differentiation, before which take out what is common. 35 minus x the whole to the power 4 is common. Also an x is common. So you have a 5x, and here you have plus a 35 minus x with a 2, because I've already taken 35 minus x whole to the power 4 out. So now take it in. So you have 35 minus x the whole to the power 4, which will always be positive. X, which could be negative or positive, I don't know. So it's 5x plus 35 minus 2x. So you have 35 minus x the whole to the power 4 into x into 3x plus 35. The 3x plus 35, okay. So that is the double differentiation value, and x happens to be 10, substituting here. This is always positive, I won't substitute. This is 10 and this is 30 plus 35, it's positive. So this is my local minimum point. Local minimum point. Read the question. What are they saying? It's about maximum. But I seem to be getting minimum. Let me check. Oh, guys, I didn't double differentiate, right? I didn't do double differentiation. Shit. So then you have to consolidate like this and do double differentiation. I have only consolidated and got an answer. What was consolidated answer was just 35 minus x the whole to the power 4 into x into 3x plus 35 is all I have. I have to do differentiation once again. I have not even differentiated it. So then in double dash of x, before which I should just put this x in, because I know only u and v differentiation. U into v, product rule. 35 minus x the whole to the power 4 into 3x square plus 35x has to be done as u and v. முதல்ல இருக்கிறது அப்படியே இது, ரெண்டாவது இருக்கிற டிஃபரன்ஷியேட் பண்ணால் 6x plus 35 plus ரெண்டாவது இருக்கிறது செகண்ட் ஒன் ரைட் இட் ஆஸ் இட் இஸ். Okay, and first one differentiated, which is 4 into 35 minus x the whole to the power 3 into minus 1. And we have to analyze whether it's going to be negative or positive. In this, you have to take out common. The common is 35 minus x, the whole cube is common. Apart from that, you don't have anything common, so this will be 35 minus x into 6x plus 35 plus 3x square plus 35x and a minus 4. So to assess whether this is going to be negative or positive, you know what is x? X is 10. Just substitute 10 here. This is 10. So which is going to make this only positive. Okay, because 25 the whole cube. So forget about it. Substitute 10 in this. Be 25. A 10 in this. 60 plus 35, 95. Okay, plus a 10 in this. Makes it 300 plus 350 into minus 4. And obviously, which is a bigger number? We just have to see which is going to be a bigger number. This is 650 into minus 4. 4 zeros are 0, 5 fours are 20, 6 fours are 24, 2600. This will be 5 fives are 25. Okay, 95 into 25. 25 fives are 125. 25 nines are 250, 250, 125. No, 250. Yeah, 225, 225. 225 plus 12. 2375. And there's a minus sign. Obviously, this seems to be a bigger number, so definitely it's negative. That shows that the answer that you got, the condition, has to be only for a maxima, not a minima. Or in other words, this x is equal to 10 stands for the local maximum point. Oh, so this should be x and 25 to get the maximum. I forgot to differentiate again, double differentiation. I just consolidated and wrote, after which I'm supposed to differentiate it again and do the f double dash of x, which I missed. Now I hope you all are clear, you all made a correction. So let's go to next sum. So let's go to 16th question. Find the positive numbers whose sum is 16 and sum of the cubes is minimum. Has to be minimum. So y is equal to 16 minus x. Substituting here x cube plus 16 minus x the whole cube. So then you can differentiate this because this is f of x. F dash of x will be 3x square plus 3 into 16 minus x the whole square into minus 1. And then so equating it to 0, it's 3 and 3 can be cancelled, but I'm hesitant to cancel now. I'll cancel in this step because I need the differentiated value to do the double differentiation, right? So let me keep it as it is equal to 3 into 16 minus x the whole square. 3 and 3 get cancelled. X is equal to 16 minus x. 2x is equal to 16. X is equal to 8. X is equal to 8. Y will also be 8. So that's the way. And to verify its maximum minima, you have to take the differentiated value and differentiate it again. So while doing so, I'll try to, okay, let's differentiate. This is 6x plus this will be 3 to 6 into 16 minus x into minus 1 will make it plus 1 here. So you can assess substituting x as 8. It's definitely positive. Are we getting minima? Did I do double differentiation? Yes. I'm getting a minima? Yeah, the cubes is minima. That's the condition, luckily. So this point is the local minimum point. If they ask you for minima, then you should substitute this value of x and y here so that you get the minima's value. Okay, so I hope you understood. So they are asking you to only find the two positive numbers. So I'm stopping with that. So 17th question. A square piece of tin. A square piece of tin has sides 18 centimeter. Is made into a box by cutting a small square edge here. You're making this is called a laddu box sum. We are making a laddu box. We're cutting one x here, square is x, and throwing it off and bending this part. Bending that part, you make it into a box which has got the uh, this is 18 minus 2x. This side will be 18 minus 2x, but the height will be x because you're folding this. Now you're folding this part up. So the height will be x, and it'll become a cuboid. It's not a cube. It's the volume of the cuboid is L into B into H, where it will be 18 minus 2x into 18 minus 2x the whole square into x. So you can do, this is your volume, it's already converted into one variable, so you can do dv by dx by doing it as u and v. 18 minus 2x the whole square is u, differentiation of x is 1, plus write x as it is, v into du is 2 into 18 minus 2x into minus 2. A chain rule, differentiation minus 2 is equal to 0. So as soon as you see this, 18 minus 2x can get cancelled. However, when you do double differentiation, you have to retain the dv by dx carefully. But for now, I know what I'm cancelling, so it's fine. So then therefore this is equal to this. So 18 minus 2x is equal to 2 to 4x into 18 minus 2x. So 18, what? 18 minus 2x got cancelled here. Yeah. So take it, that's it. 18 is equal to 6x, so x is equal to 3. So the part that you should cut off is a 3 centimeter. So that 3 plus 3, 9 is cut off. That's when you are having a. So did I do it correctly? 18 minus 2x the whole square into x. First as it is, differentiation of second, plus second as it is, differentiation of first into minus 2. First as it is, differentiation second, plus second as it is. Second as it is x. Yeah, it's perfect. So then this is the answer. X is equal to 3 is what I'm getting. So if they really want you to find the volume, you should do this. Whether you want to verify if it's maximum minimum, you should do double differentiation, for which you write dv by dx properly, taking out common. 18 minus 2x is common. Apart from that, you have one more 18 minus 2x, which is the balance in this. And here you have a minus 4x left out. And this will be 18 minus 2x into 18 minus 6x. And x itself is 3. So when x itself is 3, 18 minus 6. This will be 18 minus 18. How can it become 0? Something is wrong. 18 minus 2x. 18 minus 2x into 18 minus 2x into x. 18 minus 2x into 1 plus x into 2 into 18 minus 2x into minus 2. So it'll be 4x. 18 minus 2x therefore is equal to 4x. 6x is equal, x is equal to 3. X is equal to 3. One second. Again, did I do the double differentiation? No. See, I didn't do the double differentiation. This is just dv by dx. I just consolidated and wrote. Again, I'm forgetting how to do where I'm doing double differentiation. It's u and v, right? So 18 minus 2x into minus 6 plus second one as it is, and the first one differentiation is minus 2. So in this, what is common? Oh, no, nothing is common. So 2 is what is common. Okay, you can take it in. 8 6 are 48. 6 1 is 6 108 minus plus 12x minus 36 plus 12x. So this is negative some bigger value, which is 6 is 12 30 14 3 4 and 144 with a negative sign minus plus 24 x. What is x? X is 3. 4 3s are 12. 3 2 6 7. Definitely this answer is negative. That shows that what you got is a local maximum point. And you want the volume, substitute L, B and H value. Now that you know x is 3, just can substitute x value in here so that you get the maximum volume. Find the maximum possible volume. Are they asking it? A square piece of tin 18 centimeters made to, okay, what should be the side? That's all they're asking. So they're asking for the square part that should be cut is only 3 centimeter. That's the question. They didn't even ask you what is the volume, okay? But if they do, you should substitute and get the answer. Let's go to next question. Next question is 18th question, where you have a rectangular piece with this base is 45 centimeter and the side is 24 centimeter, and you're cutting off a side x x x x like this, and you're going to fold it. When you fold it, you're going to fold it like this. You're going to get a rectangular box, a cuboidal box. This will be 45 minus 2x. This side will be 24 minus 2x and an x. So this is also a cuboid, L into B into H, which is 45 minus 2x into 24 minus 2x into x. This is my volume, but I don't know to do U, V, W, so I'm taking this inside. 45 minus 2x into 24x minus 2x squared, so that I can do it as U and V. So let's write the first term as it is. I'm going to differentiate with respect to x. The second term differentiation is 24 minus 4x plus the second term as it is. The differentiation of the first term is minus 2 is equal to 0. So when I do that, I can take out common if I have common, or I can equate this with this and get what is the value of x. So I got a 45 minus 2x. Into from this I can take a 4 common. So this will become 6 minus x will become equal to 2 into, from this I can take another 2, so it will become 4. 12x minus x squared. I could have also taken an x common, but that's okay. So in order to find an x, 4 and 4 just gets cancelled off. So just take it in and multiply, get a quadratic equation and solve it. So it's for 6 5s are 30, 6 4s are 24, 27 minus 12x minus 45x minus plus 2x square is equal to 12x minus x squared. So it will become 3x square minus 24x with a minus 45 will become 69x. Good. Plus 270 is equal to 0. So 3 is common everywhere. X square minus 3 2s are 6, 3 3s are 9, x plus 9 3s are 27 is equal to 0. And 90 can be factorized with 5 tables, with a 45, a 5, a 9, a 3, and a 3. You should get 25. So 5 3s are 15. 23 you should get. 5 3s are 15. 5 3s are 15. Okay, 3 3s are 9. 9, no. I should get a 23. 5 5s are 25. 5 3s are 15. Oh, what should I do? What have we written here? I've written a 5 and I'm writing 45. Che. We know 18 fives are 90. So that's all, okay? So x square minus 18x minus 5x plus 90 is equal to 0. So x into x minus 18 minus 5 into x minus 18 is equal to 0. X minus 5 into x minus 18 shows that x is equal to 5 and x is equal to 18. X cannot be 18. Why? You can't possibly cut off an 18 and an 18 from a 24. It's 30. How can you cut off a 36 from 24? So it's not possible. When x is equal to 5 is the right answer. To check whether it's maxima, you have to do double differentiation. Where is the differentiated value? This one is the differentiated value. Take that and double differentiate it once again. You do d square v by dx square. So when you do that, you see, if it'll be convenient if you can take out something common. Yeah, 4 was common in this. And here also 4 was common. So you can take a 4 completely common out. And you have a 45 minus 2x into 6 4s are 24, 6 minus x plus 2 common, 4 common in this, minus 4 common. Yeah, minus is there still. 4 has been taken out. 12x minus x square. So it's just a question of solving this and differentiating. I have only not done double differentiation. I've just taken it and consolidated. You know where I'm going wrong. So careful. Let the 4 be outside. Multiply it in. 6 5s are 30. 6 4s are 24. 270 minus 45x minus 12x plus 2x square minus 12x plus x square. So what are we getting here is 4 into 270 minus 57x. Oh, there's also 12. No? So it's 69x. Oh, good. Plus 3x square. I've consolidated this. Yes. Now I can take a 3 completely out. 90 minus 3 2s are 6 3 3s are 9 plus x square. And now again I can factorize this. But I know I have to rearrange and write it x square minus 23x plus 90. And you'll get the same answer. But the whole point is not to get the same answer. It's about double differentiation. I have to get double differentiation. So if double dash of x will be 12 into 2x minus 23. And what is x value that you got? The x value that you got was 5. X is equal to 5. Substituting here, 12 into 5 2s are 10 minus 5 3s are 15 turns out to be negative, and that shows that it's maxima. That's it. Okay, so let's go to next. Next is the 19th question. 19th question. Yeah. Show that for all the rectangles inscribed in a circle, this is a circle in which you're inscribing a rectangle. The moment you do that, you have to mark this as given as a circle, so radius of the circle is a constant. So radius. This is length. This is breadth. And your whole point is to spot the right triangle. Can you see here? You have this will become L by 2. And this will become B by 2. And you have a right triangle here, which is R square is equal to L square by 2, L square by 4 plus B square by 4. So in maxima minima, we always have to spot some right triangle from which, you know, this R, capital R is a constant. Capital R is a constant. So you can write L in terms of R, B in terms of R and L, and so that's convenient. It has to have a maximum area. The rectangle has to have maximum area. Area is length into breadth. You know, you can write B square by 4 to be R square minus L square by 4. So B square is 4 into R square minus L square by 4. B square is 4 get cancelled, 4R square minus L square. B therefore is root of 4R square minus L square. A into L into B is root of 4R square minus L square. In maxima minima, when you see a square root, you are allowed to square both sides. The reason being, if you have a function, you can even square the function, but when you do dy by dx is equal to 0, you might get the same answer as x. So you are allowed to square both sides in a maxima minima. So a square, let's call it as z. Let's not call it a square. Is L square into 4R square minus L square. taking it inside 4r square L square minus L to the power 4, where 4r square is a constant, I will get a 2L minus 4L cube is equal to 0. So then 4 and 4 get cancelled. This is the differentiated value, right? Make sure you book the box, because even you're cancelling now, you should remember that for double differentiation, you should take the what has not been cancelled. So 2r square is equal to L square, or 2 capital R is L, or that's all. You got L, length of the rectangle in terms of radius of the circle. Substituting that here, you can find breadth also. B is equal to root of 4r square minus L square. What is L square? L square, oh, is root 2r. Okay, root 2r. Here it's root 2r. 2, no? It become root 2. So it's 2r square. It's again root 2r. So length and breadth have become the same. So when you inscribe a rectangle inside the circle, it becomes a square which has got maximum area. The one which has got maximum area is not a rectangle, it becomes a square. To just double differentiation verification, you take the differentiated value. What was the differentiated value? 4r square 2L minus 4L cube. Before cancellation, whatever you had. This is your f dash of x, and you're going to double differentiate it. A 4r square into 2 minus 4 3 so 12L. 12L? What is L? L is nothing but root 2r. So substituting, oh, sorry. So you first, did you differentiate 4r square with respect to L? Yeah, we differentiated. Substitute what is L? L is root 2r. 4r square to 8r square minus 12 into L is root 2r. So 8r square minus 12 root 2r. Do you think this will be positive or negative? This is, if you take an r out, be 8r minus 12 root 2. What 8r minus 12 root 2? R itself, let me think. I forgot when differentiating, I should write 12, 4 3 is 12 L square. I forgot that. L square. So it will be 8r square minus 12 L square. And L itself, is L square is 2r square. So 8r square minus 24r square. That shows that's definitely negative. Oh, sorry. I made a small mistake. I hope you all understood. It's negative. That shows that the value that you got here, the condition that you got was for maxima. The local maximum length, local maximum point of length is 2 root 2r is when the area is maximum, becomes a square. So let's go to next question. Is that 20th question? Show that the right circular cylinder of given surface area, right circular cylinder of given surface, means surface area has been given. What is the surface area? It's 2 pi rl plus 2 pi r square, total surface area. When they mention only surface area, it means total surface area, and that has been given. Given surface area such that height is equal to the diameter. Show that the right circular given is what is given. I've written here. What I have to show that is the height is equal to the diameter of the base, or height is equal to 2r. Suppose r is the radius, the height of the cylinder. That's when this is show that when at maximum volume, this is what I have to prove. So volume has to be maximized, and volume is pi r square h. You have tried one in terms of the other. You can't have two variables r and h here. In order to be able to differentiate, you should convert into one variable, and it's a cylinder, right? Yeah. 2 pi r h, 2 pi r h plus 2 pi r square. So then, therefore, you can write either r square. No, you can't write r square because there's an r and r square, so you can't segregate it. So I'll rather write a h. H is equal to s minus 2 pi r h by s minus h is equal to s minus 2 pi r square by a 2 pi r. I'll substitute this here. A pi into small r square into s minus 2 pi r square by a 2 pi r, where pi and pi get cancelled, r and r get cancelled. So thus you have an r into r by 2. Take the 2 out also. S minus 2 pi r square. Let the 1 by 2 stay outside. SR minus 2 pi r cube. Take the r inside. Let's differentiate it. dV with respect to dr, because here you know what is a constant. S is a constant given surface area. 2 pi is a constant. Only a small r is a variable. So therefore, S into dr by dr is 1.